The Big Bang is the leading explanation for how our universe began. It wasn't an explosion in space like a firework. Instead, it was the rapid expansion of space itself. Imagine a tiny dot suddenly inflating to an incredibly large size. That's the basic idea. This expansion started around 13.8 billion years ago. It's still happening today. The Big Bang theory helps us understand the history of the universe and how everything came to be. Imagine everything in the universe, all the stars, planets, and galaxies squeezed into a tiny point. This point was incredibly hot and dense. We call this point a singularity. Then, for reasons we don't fully understand, this singularity began to expand rapidly. This expansion wasn't just stuff moving outward into empty space. Space itself was expanding, stretching out in all directions. As it expanded, the universe cooled down. How do we know the Big Bang happened? We have evidence from the universe itself. One piece of evidence is something called cosmic microwave background radiation. This is a faint glow of energy that fills the entire universe. Another piece of evidence is the way galaxies are moving. Scientists have observed that galaxies are moving away from each other. This suggests that the universe is expanding, just as the Big Bang theory predicts. In the first moments after the Big Bang, the universe was incredibly hot and dense. As it expanded and cooled, tiny particles began to form. These particles eventually combined to form atoms, the building blocks of matter. Over millions of years, gravity caused clouds of gas to clump together. These clumps eventually became so dense and hot that they ignited into stars. Stars then grouped together to form galaxies, the vast collections of stars we see in the night sky. Section 5. The Cosmic Microwave Background, a baby picture of the universe. Think of the cosmic microwave background radiation as a baby picture of the universe. It's a faint afterglow of the Big Bang, a snapshot of what the universe was like just 380,000 years after it began. This radiation tells us a lot about the early universe, like its temperature and composition. It provides strong evidence that the Big Bang really happened. Section 6. Redshifts, galaxies racing away. Imagine the sound of a car engine. As the car moves away from you, the sound of the engine gets lower in pitch. This is called the Doppler effect. Light can experience a similar effect. When we look at distant galaxies, the light from them is stretched, making it appear redder. This is called redshift. The farther away a galaxy is, the faster it appears to be moving away from us. This tells us that the universe is expanding. Section 7. From gas clouds to galaxies, the building blocks of the universe. After the Big Bang, the universe was filled with vast clouds of hydrogen and helium gas. Gravity slowly pulled these clouds together. As the clouds collapsed, they spun faster and faster, forming swirling disks. In the centers of these disks, stars ignited. These stars, along with gas and dust, formed the galaxies we see today. Section 8. The future of the universe expanding forever. The universe is still expanding today. Will it keep expanding forever? Scientists are trying to figure that out. One possibility is that the universe will keep expanding at an accelerating rate. Another possibility is that the expansion will eventually slow down and reverse, leading to a big crunch. The fate of the universe is still a mystery. Section 9. The Big Bang, our place in the cosmos. The Big Bang theory is one of the most important ideas in science. It helps us understand where we came from and our place in the universe. We are all made of stardust, forged in the hearts of stars that formed billions of years ago. The universe is a vast and awe-inspiring place, and the Big Bang theory helps us make sense of it all.